Okay, good afternoon, ladies and gentlemen. Today we are going to do the partial fraction. All right, so hopefully everybody's doing well, and welcome back to the live stream. Here we go, right? So the first integral that we have is the integral 1 over x to the 2021, of course, to the year of 2021, and then we are going to add the x to it. And keep in mind, today's topic is about partial fraction, or maybe not. So this right here with a rational function, what can we do with it, right? So I'm going to look at the chart, and you guys can let me know how would you solve this. Maybe do the partial fractions, you could have like so many factors or something else. So I'm going to look at the chart. Let me know how would you solve that. All right, Gabriel, you got it. So here's the deal. Usually, we only factor out the x to the smaller power, but here, if you are willing to factor out x to the bigger power, namely x to the 2021, then this right here will be very, very nice. And you end up with 1 plus x to the 2020, but it will be negative, right? So now this will be the new denominator, and this is going to be so nice. Have a look right here. Here becomes the integral, and then we are going to keep this on the bottom. So we have 1 plus x to the negative 2020th power. And then we will see that this right here, we can bring that to the numerator, and we will just get x, but you make that into a negative exponent, namely negative 2021. And do we see it? Hopefully we do. Because right now we can just do u sub, let u equal to the bottom, let u equal to 1 plus x to the negative 2020. And then we are just going to do the usual business. You see that du is just going to be, we get negative 2020, and we get x to the negative 2021 dx. And I'm going to isolate the dx, so you will see that dx is equal to this guy, right? Du over this guy, negative 2020 x to the negative 2021. And of course, now let's take this integral to the u world. We will see that this becomes the integral, and let me just keep that on the top, x to the negative 2021 over the bottom is just our u. And then the dx is just that, so we have du over negative 2020 x to the negative 2021. I like to do it this way because I like to show the cancellations. So you see this and that cancel, and you can see that exactly what we need. This right here, we have the negative 2020 on the bottom. So we're going to write that down first. We have negative 1 over 2020. And then we just have to integrate 1 over u in the u world, which we get ln u, but u is equal to what? This guy. So we're just going to put that down. 1 plus x to the negative 2020. And this guy is always positive, so you don't need the absolute value. We can just put down a parentheses. And I just realized I ran out of space to put on the plus d. So I'm just going to put on a plus d right here and make it pretty big. So this right here is the first one. And the truth is, whenever you have x to some power here, and then plus x to the first, you can always do that. Yeah, so you can have the x to a 17th power plus x. You can do this. So this is one of my favorite integration without the partial fraction. All right, so again, hopefully everybody's doing well, and hopefully you guys are following along as well. And again, all these questions are from Calculus 2. And next week, I will do something else, maybe not integrals anymore, because we have done the integration by parts, trig sub, and also partial fraction today. So these are the main topics from Cal 2, right? Next week, we will do something else. All right, so let's see how you guys are doing. You guys can let me know if you have questions, just leave in the chat, things like that. Number 2, again, another integral, 1 over, here we have x plus 3 square root of x, and then plus 2, and then we have the dx. For this one right here, we can do partial fractions right away because this right here is not a rational function. Because for a rational function, we must make sure that we have x to some positive whole number power. This is technically x to the 1/2, right? Here's the little thing that you can keep in mind. Whenever you have an expression that involves square root, just go ahead and do a u sub and see what happens. So I'm going to take a u sub, let u equal to square root of x. And then you will see that square both sides, we get x equals u squared, and then differentiate both sides, we get dx equals 2u du. And this is going to work out very nice. You will see that this becomes the integral. On the top, we have 1. On the bottom, x is the u squared. And then plus, here we have the 3, and the square root of x is the u. And then we have the plus 2. And then we have the dx being 2u du. So allow me to put this down right here. We have the 2u here, and then the du here. And that is very nice. Now we can do the partial fraction. Because I don't think there's any way to avoid partial fractions for this. To do so, I'm going to factor the bottom, and this right here is pretty nice. It's just u plus 1 times u plus 2. And then you can see that, and again, I should have mentioned that because the degree on the top is just 1, and the degree on the bottom is 2, you can do the following. If the degree on the top and on the bottom are equal, then you will have to do long division. So we are going to go ahead and proceed. Here we have the integral, and then we are going to just have two fractions now, because I'm going to do the partial fraction right here. For the first fraction, we will have u plus 1 on the bottom, and for the second fraction, we will have u plus 2 on the bottom. Now, this is my favorite way to do partial fraction, and works for this kind so well. The cover-up method. So this right here, it's going to be a number because the bottom is just linear, right? And they have distinct factors. So what we are going to do is go back to the original here, and we are going to cover up the same denominator, and we have to ask ourselves, how can we make u plus 1 being 0? Well, u has to be negative 1. Then we are going to put negative 1 in here and here. So you can just do this in our head. So 2 times negative 1 is negative 2. And then negative 1 plus 2 is 1. So we have just negative 2 pretty much. But let me just put it as negative 2 over 1. Now, don't worry, we have another chance to practice that. To figure out this number, well, you go back to the original and you cover up the same denominator. And you are going to plug in the number that can make this factor equal to 0, which is negative 2. So you're going to use u is equal to negative 2, put in here and put in there. So 2 times negative 2 is negative 4 over negative 2 plus 1, we get negative 1. So altogether, you will just get positive 4. So right here, we can see that we're just going to integrate that because this is just going to be negative 2, right? So we get negative 2, and then the integral of 1 over u plus 1 is just absolute value of u plus 1, but we know u is equal to square root of x. So I'm going to put that down right here already. And I noticed that square root of x plus 1 is always positive. So we are going to come back here and erase the absolute value, and we're just going to put down parentheses. And you know what? I think I can finish that in here. So let me not go over there. Let me just put on the answer right here because this is not so bad. So right here, this is negative 2, and then absolute ln, and then we put down parentheses, u is square root of x, and then we put down plus 1. And then this is going to be positive 4, and then integrate the u plus 2 on the bottom. We get ln, u is square root of x, and then we add 2 to it. Absolute value is not needed, so just parentheses, and then in the end, put down the plus c. This right here is it, right? So it's not so bad. All right, so even though this question didn't look like we needed to use the partial fraction, but technically we should. Yeah, and just do a u sub first. That's the deal. All right, so welcome everybody. We have more and more people coming, and now we are going to be doing question number 3. And by the way, because of the daylight saving, so there was a time change. That's why I put it into 2 o'clock today, and also had a department meeting earlier. So yeah, so if you are from another country, then you will feel like 2 o'clock right now. I have the little clock right here. You guys can see that. Yeah. And by the way, I got this for you guys as well in the background. So you guys can see that later on. You got this when we are solving like hard questions. And I also have just a daily coffee from Starbucks. All right, so now let's see. how we are going to do the next one? For number 3, I'm going to ask you guys for suggestions. We are going to look at the integral x squared plus 1 over x to the 4th power plus 1. All right. Partial fractions for this x to the 4th power plus 1, it's pretty hard to factor. It's factorable, but it's pretty hard to factor. So I don't know. I'm going to look at the chat and let you guys tell me what we should do. Alright, Ardu Jabad, thank you for your suggestion. You said divide everything by x squared. That's perfect. And that's exactly what we are going to do. So here's the deal. We are going to divide, which is the same as multiply by 1 over x squared. Right? So let's see what will happen. And this is going to work out very nicely. You will see. Well, and you also have to do some completing a square in the following way, right? So let me show you. Here, this right here is just 1, and then we have 1 over x squared, and then of course this times this is x squared, and this times this is plus 1 over x squared. Alright, that's pretty nice. Then, what do we do next? Alright, what do we do next? Aha, yes, from Abdul Jabbar. We are going to factor this in a slightly unusual way, right? Because this is actually almost a perfect square. And let me just put that down for everybody so you can see what's going on the bottom much better. So let's just make an observation, OBS. Right here, when we have x squared plus 1 over x squared, technically, let's look at it like this. For the x squared, which is the same as saying x to the 2nd power, and then the 1 over x is like this, 1 over x to the 2nd power. This is almost a perfect square if we have something in the middle. So what do we want to do? And the reason that we want to do this is because on the top, this is also going to be pretty nice. Have a look. We have 1 plus 1 over x squared. Well, what we are going to add here is that we are actually going to have minus 2ab, because this is a squared and this is b squared already. If in the middle we have minus 2ab, which is just 2 times x times 1 over x, then this becomes a perfect square. You can also put down plus 2ab plus 2 times x times 1 over x. That will also complete the square as well. However, you will see that for this part, this is going to give us what we really want. This becomes x, and then because of the minus here, it's a minus here, and then we have 1 over x like so. The reason we want to do this is because we can then just do a u sub, let u equal to x minus 1 over x, and the differentiation for this is just going to be what we have on the top, and that's going to work out very nicely. Of course, we cannot just subtract the 2x minus 1 over x out of nowhere. It's okay. All we have to do is just go ahead and add this at the end. So I will put down plus 2 times x and then multiply by 1 over x. But this is really just a plus 2. So that's what we have on the bottom. And let's just go ahead and put that down here. So I'm just going to bring all this over there. So what we are going to do is, technically, we're just going to put down plus 2 and then minus 2. And we will see this becomes the integral. On the top is still 1 plus 1 over x squared over this guy is just going to be this guy. So I'm going to write it down. X minus 1 over x and then square and then and then plus the 2. So let's put that down. And then we still have the dx right here. All right, so this is the change. Change for the good, actually. It's very, very nice. All right, so let's see. Right here, we are going to do a u sub. I'll just put a u right here. Let u equal to the inside, which is x minus 1 over x. And then differentiate that real quick. We get du just being equal to 1. And the derivative of 1 over x is negative 1 over x squared. Negative times the negative gives us the positive, and then we have the 1 over x squared, and then the dx. And see, that's exactly what we have on the top. That's why earlier we chose to minus instead of plus, so that this works out very nicely. All right, then what's going to be is the integral. This altogether is just our du, so I'm just going to put that on the side, and we will just have 1 over, this is just the u, and we have that square, and then the 2. Because right here we have plus, so you know we are going to use the arctangent formula, so put down square root of 2, square, and then the du right there, right? So now let's go ahead and just finish this. To integrate 1 over u squared plus a number square, it's going to be 1 over this number, which is square root of 2, and then multiply this by the inverse tangent of u, and u is equal to this, so I'm going to write that down right here, x minus 1 over x. Right, this is the u, and then we have to divide it by the a, which is the square root of 2. And let me just write it down right here, 1 over square root of 2, like that. So that will be the input. And altogether, this is it. So of course, put on the plus c. That is it. So one of my favorite ones as well, the little cute one, if you try to use partial fraction the regular way, then there's a lot of factoring out the x to the 4th power plus 1, and it's going to be really, really long. In fact, I have done the integral of just 1 over x to the 4th power plus 1. No trick, it's just straightforward integration by the partial fractions, complete the square, lots of algebra and all that. All right, so that is what we have. All right, so take a look before I erase that. I think this is rather crazy, so I'm going to pause for a little bit more. Let's see what you guys have. All right. And in fact, I had a rather difficult time to come up with interesting partial fractions questions. I think I don't really have that many partial fractions integrals questions. So if you guys know any interesting or tricky partial fractions integrations, not necessarily like super long ones, you can leave a comment and let me know. We will do one that's like pretty long one, which is the one that's coming. So here we go. Number 4, I have to make sure I write this down slightly smaller. 1 over x to the 3rd power plus 1 dx. You know how to do this one? Just do it. No tricks, no gimmicks. Just straightforward partial fractions, completing a square, and lots of work. Hopefully I can finish everything on this whiteboard, but we will see. All right, here we go. We are going to factor this guy. This is the sum of 2 cubes. It's not so bad. The formula is just going to give you x plus 1 times x squared minus x, and then plus 1 squared, which is just 1. So that's the factoring for that. Now, we are going to do the partial fraction on the side. So you see that we have 1 over that for the denominator. So we have x plus 1 times x squared minus x plus 1. And then break this down into 2 fractions. The first one will have just a constant on the top. So I'm going to put that as a. And then over that. And then next we have this as the denominator, which is x squared minus x plus 1. But this right here is an irreducible quadratic. So on the top, we must have a linear. So we put down bx plus c. Good news. We can use the carve-out method for a. Bad news. That's the only one we can do. Anyway, let's go ahead and find out what a is. So to find out a, you see, we have x plus 1. We go back to the original, and then we cover the same denominator, and we just have to make sure that x becomes -1. And then we're just going to put it here and here. So this time we'll show you guys the word. We get 1 over, we get -1 squared minus -1, and then plus 1. Work that out, we get 1/3. So that's what a is. A is equal to positive 1/3. Okay, fractions time, of course. Now, to solve for B and C, from my experience, I think the students are more okay to do the following way. You can also just let x equal to like 0 or like 2 or 1 and then plug in and then just solve for the B or C. But the following way, I think it's straightforward and then more students are okay with this right here. So I'm going to do that. All right, so I'm going to multiply everybody by the lowest common denominator, which is just this and that. So on the left-hand side, we will get 1. And then because a is equal to 1 already, so that's good. Imagine we multiply everybody by this. Then x plus 1 cancel. So we just have to multiply the a value with that, which is 1/3 times x squared minus x plus 1. And then we are going to just write this down plus bx plus c. This will cancel, but we have to multiply that with x plus 1. And then again, just do it. Just do it. So this right here is going to give us 1/3 x squared minus 1/3 x plus 1/3. And then multiply this out, we get plus bx squared. And then that's equal to bx plus 1, which is plus bx. And then plus cx. And then lastly plus c. Oh, such a long expression, huh? All right, you don't really have to continue that much. Pay attention to the x squared term, which is this and that. You can see that we get 1/3 plus b, and then we can factor out the x squared. So that's the only x squared terms that we have right here, right? But on the left-hand side, we don't have any x squared term. So what does that mean? That means this guy has to be equal to 0. So right here, we know that 1/3 plus b has to be equal to 0. Thus, we know b is equal to negative 1/3. Pretty good. And then we just have to find out c. You don't have to collect the other terms if you don't want to, because there was 3 things to do. So I'm just going to put down da 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 and then x. And then you will see that here we have 1/3. Here we have c. These are the constant terms. On the left-hand side, we have 1. On the right-hand side, we have 1/3 plus c. So that means 1/3 plus c has to be equal to 1. And then do your little fractions. C is equal to positive 2/3. So that's pretty much it for the partial fraction part. Now the integral. We are not doing anything with the integral yet. So cannot be too happy at the moment. All right, so that's the partial fraction. Now I'm going to go back and I'm just going to put down what we have. So right here, first, we are going to break this down. The first fraction is 1/3 and x plus 1 on the bottom. So I'm going to put down the 1/3 in the front. And then we're just going to focus on the integral and then 1 over x plus 1. And let's close that. Next, we have the bx plus c. And the b is this and the c is that. Well, notice that they have the 3 on the bottom. So I would like to factor out the 3 as well. But because we have the negative here, so I'm going to factor out a negative 1/3 right here. Right? And I know I cannot fit everything on the same board, so I will have to erase this right here. All right, so we factor out negative 1/3, and then I will have the integral. Then we will just have we'll just have x, right? And then c is just 2, so we have x plus 2 over that x squared minus x plus 1 dx. But if I put down 2 right here, you see negative 1 times that is negative 1, negative 1 times 2. It's not that. This right here should have been negative 2. All right, so take a look first, right? So just plug in and then just work out the parentheses and work out the negative numbers. Just be really careful. If you multiply in the negative 1/3 into here, you get that. If you multiply this into here, you get c being equal to that. So that's the gentleman, right? So I cannot really fit in everything here. So let me see. Let me try. 1/3 and c is equal to 2/3. All right, so not so bad. Whew. Told you it's not so easy. If I'm taking a test, I can, do this one happily, but I won't be too happy of doing this one. But it's not so bad, right? Let me take a look. Anybody want to say anything? Now how we can do this one? That one's easy. How about this? So I'm looking at you guys. When I turn away, I'm just looking at the chat. So I want to see who can give us any suggestions for that. We cannot do long division because the top is degree 1, the bottom is degree 2. So long division cannot be done for this. Use substitution, it's not so, it will work, but it's not the best, I would say. And in order to do use substitution, you actually have to break this apart into this integral and then the other integral. So not too ideal either. All right, this is what I would like to do. Have a look on the bottom. X squared minus x plus 1, right? I kind of have to take it back because we are still going to do use substitution. Not in the usual sense. We are going to do it this way. Check this out. On the bottom, let me just put a note right here. If we differentiate the denominator, x squared minus x plus 1, we get 2x minus 1. Nice. So, this is my favorite way to ask questions when we are solving hard equations or integrals. Wouldn't it be nice if the top right here is 2x minus 1? That would be so nice, isn't it? Because then we can just do a very easy use substitution. So let's try to make that happen. Well, we need to have a 2x. We need to have a 2 right here. It's okay, just multiply this by 2. No, not really. We have to do the same for the whole thing. And this is not complete yet because when you multiply the top by 2, make sure you divide by 2 as well. So we are going to do that. And you see, this right here on the top becomes what? 2x minus 4. But we want to have minus 1. Can we write it as minus 1 and then minus 3? Yes. Yes. Even though it's really strange, but it works. And if it works, we will be happy. That's the idea. So now, let's see. I'm just going to write that down. Shall we integrate this already? I don't know. I will. Why not? So this right here, ladies and gentlemen, I just want to get at least like the first part of the answer right. 1/3 natural log absolute value of x plus 1. Done with the integration. Here we have the minus 1/6, right? And then let's put down a parentheses because we still have to break this down into 2 integrals. The first integral, I will put this down in blue. Integral 2x minus 1 over that for the denominator. Right, so that's the blue integral that we have. Next, we have the minus 3 inside of the parentheses, so it still is minus 3. And then we have the integral, and that for the bottom, so 1 over x squared minus x plus 1, and we have the dx here, right, parentheses. All right. This right here, again, we can do it pretty easily. This right here, we have to do the completing a square as well, just like what we did in the previous question. So let's just make it happen. Do it in red. This right here, have a look. This is the same as saying x squared minus x, and then take 1/2 of this, which is just negative 1/2. Square that is 1/4. So you want to see a 1/4 here. But originally, we have a plus 1. So this right here is technically, just break it down as 1/4 plus 3/4. This right here is a perfect square. What's the perfect square? X minus 1/2 square. And because you know we will be using the inverse tangent formula again, so we are going to put this inside as square root of 3 over 2 and then square. So this is the same as that. And again, you can just do u sub in your head. U is equal to x minus 1/2 and dx is the same as du, so nothing too much to worry. So now, ladies and gentlemen, let's finish this right here. First one, we have 1/3 ln absolute value of x plus 1. Done. Next, distribute this so we get negative 1/6. This is in blue. It should be in blue. it's just going to be natural log of the bottom, which is x squared minus x plus 1. And the truth is, this right here is always positive. Thus, you can just put down a parentheses, and then negative 1/3 times negative 3, we get plus. So I'm going to show you negative times negative plus, like that. And then we have 1/2. So I will put that down right here. And then we have to do the integral of 1 over this guy times that guy plus that guy square, right? So the formula is 1 over this guy, which is the reciprocal of this, namely 2 over square root of 3. And then we multiply by the inverse tangent of the u is this, so I'll write that down, which is x minus 1/2. And then again, divided by a, which is that, so I will multiply by 2 over square root of 3. So that's what we have. And allow me to just cancel the 2 right here. That's plus 1 over square root of 3. And because we're all adults now, we don't have to rationalize the denominator. So we're just going to be done for this. All right. I'm pretty happy about fitting at least all the answers on the same line. So that's what we have, right? That's a pretty fun one. If you are taking Cal 2 though, this will be a really challenging one. And this is the one that you don't want to see on the test. But if you do these steps, it will actually save you a good amount of time. And yeah, so have a look right here. All right, Super Cat, you said that's a good one. Thank you. I'm glad that you like this as well. Now, we have 4 more to go. And you guys can also suggest me on what topic that we should be doing for the live stream. I will try to make live stream every Tuesday around the same time, 1 or 2 p.m. it depends. And I will try to, do a live stream for an hour. So not too long, not too short, right? In my opinion, for that. And I know I'm using an eraser because I recently made a video that says we should use the tower for this, but like eraser looks better when you erase it, But like, so that's like the behind the scene. I will show you. This is how the tower looks like. But yeah. So anyway, all right, number 5. All right, number 5, it's going to be a semi-long one as well, but not so bad. Integral 1 over. It might be the craziest looking one that we are doing today. X to the 4th power plus x to the 3rd power plus x squared plus x. And then we have dx. All right. Here, we are going to be... Any tricks? I will ask you guys first. So I'll look at the chat. And I'm also going to kind of look at the chat and make sure your comments are appropriated, right? Otherwise, I will have to remove you. So that's why I'm doing. So just give me a second for that. All right, so Super Cat, you're suggesting us that we should just factor it out and do the partial fraction, right? Yes. But this one, I will say, is slightly easier than the one that we did earlier, but still pretty hard. Well, we'll see. You guys let me know if it's hard or easy. Anyway, first, we are going to factor out an x from everybody. So we have x and then x to the 3rd power plus x squared plus x plus 1. And then we can factor by grouping this and that. So you can see this is x. From here, we can factor out x squared, and then we get x plus 1. From here, we can factor out 1. So I'll put down plus 1, and then we still get the x plus 1. So we get x times, let's put down x plus 1 first, and then we have the x squared plus 1, like that. So again, partial fraction time, do it on the side and do it in blue, of course. ladies and gentlemen, here we have 1 over x plus 1, x squared plus 1. All right, the first one is just x on the bottom. So we have some numbers, so let's put down a. Next, we have some constant over x plus 1. And lastly, we have a linear term because this is an irreducible quadratic. So cx plus d over x squared plus 1. Now, good news. Yes, a and b can be done with the carve-out method. So let's go ahead and do that. So that's a good news anyway. A equals when x is equal to 0. Cover up the same denominator. Put 0 in here and here. So we get 1 over 0 plus 1 times 0 squared plus 1. So this is just equal to 1. B, well, cover out the same denominator. X should be negative 1. So let's write that down. And then we are going to put this in here and here. So we get 1 over negative 1 times negative 1 squared plus 1. And this is 2. 1 plus 1 is 2, and then times that, which is negative 1/2. I know, I don't know why every time I say 1 plus 1 is 2, and then people leaving a comment and people get really happy about that. Anyway, I didn't do anything wrong. 1 plus 1 is 2. Anyway, for C and D, let's just multiply all everybody by the common denominator. So we get 1 on the left-hand side. A is 1, so let's write that down. And the x will cancel, so we just have this times that. So it's x plus 1 times x squared plus 1, right? Next, x plus 1 will cancel. B is negative 1/2. So we have negative 1/2, and then we have x times x squared plus 1, like that. And then lastly, we have the plus cx plus d. X squared plus 1 will cancel, so we just have x times x plus 1. All right, and then just kind of simplify the right-hand side. So let's see, this right here is going to give us x third power and then plus x squared plus x plus 1. This right here is the same as saying x to the third power plus x, right? Yeah, and then just distribute the negative 1/2. So negative 1/2 x to the third power, and then negative 1/2 x. Next, you multiply this out, and this is really x squared plus x. So you do this times that, we get plus cx to the third power, and then cx squared, and then dx squared, and then lastly dx. Well, bad notation, but whatever. Yeah, we're not differentiating anything here, so anyway. All right, let's see. Well, let's collect the like terms for the coefficients of x to a third power, because there's nothing here, right? So here we see this is 1x to a third power, and then minus 1/2 x to a third power, and then plus cx to a third power. What that means is that we must have 1 minus 1/2 plus c. All this right here has to be equal to 0. Then we get c should be negative 1/2. Right? C should be negative 1/2. All right, and let's see, maybe let's do the constant term. So the constant term here, we have 1, and then doesn't really do us any good because we have 1 is equal to 1, so it didn't really do us any good. We have to have something that with d. So let's see, we are going to do this, plus x, and then minus 1/2 x, and then plus dx. So that's 1 minus 1/2, and then plus d. This right here is going to give us the coefficient of x, but there's nothing here, right? 0x. So this right here is equal to 0, and d, guess what? It's also equal to negative 1/2. Oh my god. All right, now it's kind of weird, but take a look. If you guys are following along, check the computation for me real quick. Are we good? If we are good, just leaving the chat so that we are good to go. I just want to make sure that we have the correct numbers before we move on. Good? All right, so thanks for verifying all that. Now, don't forget we still have to go back there and do our integration. This right here, because the denominators are pretty nice, so we don't have to do anything too crazy. So that's why I said it's easier than the one that we did earlier. Anyway, first we have to integrate. A is equal to 1, so we just have 1 over x plus 1. So let's close that. Next, b is equal to negative 1/2. So I'm going to write down negative 1/2 here, integral, and then we have the 1 over x plus 1, right? And let's close that. Next, we have the cx, and that's write it as cx over that. Cx, c is equal to negative 1/2. So I'm going to have negative 1/2 integral, and then the x over that, so we have to put that inside of the integral. And lastly, we have d over that. D is equal to negative 1/2, so I'm going to write down negative 1/2, and then we have the integral of 1 over x squared plus 1 dx. All right, seriously, a is 1 and b, c, d, they are all negative 1/2? Are we right? I hope that's correct. Are we good? Like B, C, D, they are all negative 1/2? I don't know, I just look kind of, it's almost like too good to be true. Oh, thanks. The first one is just 1 over x. How about the coefficients? A, B, C, D. Did I get A, B, C, D right? I think nothing wrong. Let me just double check. I hope nothing wrong. I don't know, because they are just looking too good, you know. B, C, D, they are all negative 1. So I'm showing you guys how I solved the questions around SPA too, you know, because yeah, didn't really prepare for this, and yeah, so I would like to see the coefficient seems fine. Auto dropout, thank you so much. And then Franklin, thank you. Hello. And then let's see. All right, so we are good to go. Let's just go ahead and integrate everybody then. First one, natural log, absolute value of x. Second one, minus 1/2. Again, natural log, absolute value of this guy. Right? This, be really careful. Do the u sub in your head. You need to have a 2 right here, so divided by 2 right here. So this becomes negative 1 over 4. And then you have the ln, and you don't need the absolute value because the bottom is just x squared plus 1, right? Actually, let me put that down below there. So again, this is negative 1 over 2 originally, but because you do the u sub, u will be x squared plus 1. The derivative is 2x. So you need a 2 here. Be sure you divide it 2 right here as well. So this right here is actually negative 1 over 4. And then you have the ln x squared plus 1, and we just need the parentheses for that. Lastly, negative 1/2, and this guy is just inverse tangent of x. Very, very nice. All right. So you can see that a lot of the partial fractions questions is just that. Just do it. That's all. Yeah. Have a look. And I'm pretty happy that I'm fitting everything here. So pretty good. Okay, so we have 2 more to go, and you guys know I have some special functions for you guys at the end. So we'll see if they are going to be any useful for like solving different integrals or not. All right, number 6. Let me take a look at the question. This is a really fun one. We have the integral of 0 to 1/2, and then we have 1 over. Here we have 1, and then plus x squared plus x to the 4th power forever. We don't stop. So dot, 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 dx. Okay, a lot of people will say, just use the geometry series, just use the best friend. But for this one, Technically, in my class, we are not there yet. We haven't covered the geometry series yet. And if you are my student and if you're watching, thank you, you are doing wonderful. Here, let's do it with long division. Have a look. So pay attention to here. Let's look. Here we have 1. Put the 1 inside and then put the 1 plus x squared plus x to the 4th plus dot 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 on the outside. So let me give myself a little bit more space. This is 1 and then 1 plus x squared plus x to the 4th on the outside. So this is a very unusual way to do long division, but it works. First, I need a 1 because 1 times 1 will give me this 1. 1 times all that is just plus x squared plus x to the 4th plus dot 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 forever. Subtract as usual. 1 minus 1 is 0, and then all that becomes negative. So we have negative x squared minus x to the 4th power, and then minus dot dot dot. Next, we are going to minus. What times 1 will give us negative x squared? Well, here we have the minus already, and we need to have x squared there. So you see, this times all that becomes negative x squared, and it works out very nicely. It becomes negative x to the 4th power minus dot dot dot. Subtract, guess what? Remainder will be 0. Technically, you should check the x value in order for this to work. This right here works because we are just going from 0 to 1/2. This right here only works if the absolute value of x is less than 1. So I will just make a note. In this case, we have to make sure that the absolute value of technically x squared, because the input is x squared because of the geometry series. So that's why it works, right? Anyway, we are going to go back here and we are going to see this is just the integral from 0 to 1/2. The inside here is just nicely equal to that guy, namely 1 minus x squared. And of course, that becomes the question and we just have to integrate that. Yeah, that's it, seriously. So let's see how to do that. So we get x minus 1/3, x to the 3rd power, and then we are going to be plugging numbers, going from plugging 1/2 first and then plugging 0. So we get 1/2 minus 1/3 times 1/2, and then 3rd power. That's the first, and then minus plugging 0, we just get a bigger, we just get 0. The challenge part is if I can add fractions. 1/2 minus, this is 1/8, times that is 1/24, and then multiply by 12, multiply by 12. So we should get 11/24. So ladies and gentlemen, final answer, 11/24. All right, and for this one, you see, we can avoid using the geometry series, especially if you're in Cal 2 and that we haven't covered Cal 2 yet. So you can do long division. And that's actually one of the ways to tell people why the best friend is the best friend formula and all that stuff. But anyway, we'll do series by the end of the semester. Actually, maybe next month or so, after we come back from spring break, I will prepare some series questions because I'm going to be teaching series in I'll be teaching series in my Cal 2 class next month. All right, so, man, the 1/x to the 3rd power 1, that kind of took a while. Number 7, here, given. So you know I'll give you guys a special function, given integral 1/, if you have x squared minus 1 dx. Let me just help you out. This right here, we can answer it as negative. This is called the hyperbolic tangent, right? But inverse that, right? So this is almost like a special function, but you actually cover this in Cal 2, so it's not so special. It's not so like out of nowhere. You can actually express this in terms of natural log, so it's not too special, but we are just going to use this right here, right? All right, so we are going to integrate. Well, we are going to integrate what? Square root of x over x squared minus 1 dx, right? As you can see, for now, it's kind of like we should not do partial fractions at the moment because the degree, it's not really a polynomial on the top. It's a square root. Don't worry, just do some u sub and then hopefully things will work out nicely. Let u equal to square root of x. And then square both sides, x is equal to u squared, and you see dx equals 2u du. Right? Okay, so this becomes integral on the top is the u. On the bottom, x is u squared, so we have u squared, but then we still have to square that, and then minus 1. Dx is that, which is 2u du. That's what we have. Now this becomes rational. Yeah, this is also sometimes called the rational substitution. Usually I don't say that because this is just u sub, and you will end up with a rational function. Yeah. Okay. All in all, this and that becomes 2u squared over, we can factor out the bottom. This is difference of 2 squared already. I'm going to factor as u squared minus 1 times u squared plus 1 du. Alright. There's actually a very nice way to solve this. You can keep going and factor this out, but you don't have to. Life doesn't have to be that hard. There's a very nice way. I want to see if you guys can tell me. So I'll look at the chat and let me know what you guys have. All right, I know Abdul Jabbar got the answer. How about other people? I want to just kind of wait for other people to see if you guys can also. Yeah, Abdul Jabbar saw your answer already. Let me see. Lucas, you said bring out the 2. You don't want to do that because this right here actually works out very nicely. You will see. So Muhammad, you said subtract 1, add 1, subtract 1. That's also one of the people. Inverse trig. All right, so let's have a look. This is how we can do it. Let's do this again. Everybody knows 1 plus 1 is equal to 2. But we know 2 is the same as 1 plus 1. But in this case, we are not really saying that, but rather, let me write this down first. Instead of having 2u squared, we're going to break it down because we know 2u squared is the same as u squared plus u squared, isn't it? Yes, it is. And now, this is the best thing that I like to say. Wouldn't it be nice? Wouldn't it be nice if right here we have a minus 1? Because u squared minus 1, and that can cancel out. That's so nice, isn't it? If it's nice, then just make that happen. So right here, I'm going to minus 1. And you know the deal. Right here, we are going to add 1. So have a look, ladies and gentlemen. This right here, we are going to pair this 2 with the denominator. We're going to break it down. This and that will cancel. So for the first integral, we actually just have to integrate 1 over that. Namely, u squared plus 1 in the u world. Secondly, we do this over that. And the u squared plus 1 will cancel. So we just have to do 1 over u squared minus 1. That's so nice, isn't it? Now, have a look. This guy is just the inverse tangent, the original version. So we'll put down, here we have the inverse tangent. And we have the input being u, and u is equal to that. So let's just go ahead and put that down already. Right? This guy, well, I gave you guys the answer here already. Here we have u, right? So just make sure that we use u. So right here, make sure that it's negative, so it's minus, and then we have inverse. This is the wrong spelling for that. Inverse hyperbolic tangent. Inverse hyperbolic tangent, and input is u here. And u is equal to square root of x. So you put the square root of x right here. And guess what? We are done. Let's let's have the biggest plus c. Right? Let's have the biggest plus c. Plus c. Maybe it's not the biggest, but probably the biggest for today. Not the biggest ever though. How's this? Pretty good, huh? All right, so have a look and then we'll do the last question. All right. I do have a second channel. I don't know if you guys know about it or not. Black pen, red pen, fast. And recently I did a biggest integral. So if you guys have seen that video, then you know the reference of this biggest C. So yeah. Man, that sounds like so clickbait. I can say something like, I added the biggest plus C ever to this integral. Anyway though. All right, hopefully you guys are having fun so far. Last question, special function. So number 8, given integral, when you have e to the x over x dx, this is what we call the exponential integral function. So capital E, I, and then the input is x. And so this is the one that we are going to use. If you have been to my live stream the previous 2 times when we are doing integrals, you know we use special functions, just to make it special. Here we are going to integrate e to the x over x squared minus 1 dx. It's quite similar to number 7. By the way, this is not delta, this is 8. So, shall we just do a u sub, let u equal to e to the x and then see what will happen? What do you guys think? Alright, so what do you guys think? Shall we just do some u sub, let u equal to e to the x and then just do what we did for question 7? So I will take a look for another 15 seconds or so. Okay, you guys are saying just do partial fractions. Can commute. Okay, I like your name. Bobby 43 rocks. Partial fractions. All right. Okay. Jose, you are saying we are going to use the Taylor series. That will be slightly overkill. We don't have to do that. All right. Here's the deal. Ready? Of course, the bottom can be factored in x minus 1, x plus 1. Now, on the top, we have e to the x. That's not a polynomial, so we shouldn't be looking at this as the partial fraction the usual way. But it still works. Check this out. We're going to write this down. Do not put the e to the x on the outside. Don't do that. That's just horrible. That's just wrong. Don't do that, right? Don't do that. But instead, we can actually just put it on the side first. And then we are going to look at the partial fraction of 1, right? This is like 1 over that. So 1 over x minus 1 plus 1 over x plus 1, right? So we are going to do that. Now, do the cover up, of course. To figure this out, we go back to the red part, cover the same denominator, x should be 1. You put in here, 1 over 1 plus 1 needs no introduction, it's just 1/2. Here, to figure this out, we go back to the same denominator and cover that up. X plus 1 should be 0, meaning x should be negative 1. You put it here, 1 over negative 1 minus 1 is negative 1/2. This is still legitimate. If you combine these two fractions, multiply by e to the x, you still get that. That's still legit. And the reason we want to do that is because, notice here, we have x to the first power. X to the first power, right? We want to have x to the first power. That's why we want you to break it down, right? That's why we wanted to break it down. Now, we are going to break down this into 2 integrals. First integral, put the 1/2 in the front. So we have the 1/2. Look at the integral, and then e to the x on top of that. So e to the x over x minus 1, and let's close that. Then do the same thing, negative 1/2 integral, and then e to the x over x plus 1 dx. All right, good. Now, in order for us to utilize this right here, this input and that input have to be the same. Have a look. This is x minus 1. So really, we want to have x minus 1 here. But of course, if we do that, that changes the whole thing. But don't worry. This right here is the same as saying e to the x times e to the negative 1. So we can just multiply this by e to the first power. So if you multiply this out, you will still get e to the x, right? And don't worry, we'll do another example right here. Here we have x plus 1. So really, we should have x plus 1 right here as well. But this really means e to the x times e to the first power. So we should really have e to the negative 1 power, so that this times that will cancel to be 1, so that we wouldn't change the whole thing. All right? Now, ladies and gentlemen, we'll come to the last question of today's live stream. Thank you guys so much for coming. And now, let's finish this strong. Okay, here we have the 1/2. This is e to the first power. We shall multiply this with 1, and I shouldn't be using my finger. Put a constant in the front. So, look at e to the x minus 1, and then this is also x minus 1. Do a use up real quick. Let u equal to x minus 1. du is the same as dx. No worry. So, this right here is just exponential function, exponential integral function of u, and u is just x minus 1, so you just put that down right here. Secondly, we have the minus 1/2, and here we have e to the negative 1. Let's bring that down to the denominator. E to the x plus 1, do a use up. Same idea, we get exponential integral of u, which is x plus 1. And then, we are all done. Put down plus c. Of course, this is it, right? So take a look and let me know if you guys have any questions. John, you want a big plus c? All right, let's finish with a big plus c. I don't know if I can make it any bigger than what we did earlier. So let's see. You choose, John, you choose what color? Black, red, or blue? You choose. So John, let me know what color. No, John, because John said big plus c. All right, so John, you want blue. So we'll do blue. And I'll try to make it as big as possible. But I will have to make it skinny though, because, let's see. Big enough? I think so. So much better. All right, thank you guys so much for coming, and then I will come with something for you guys next week. Maybe no more integrals for next week, and I'll try to think about some interesting equations or some other things maybe from Cal 2, right? Bye.